Okay. So Chapter 3, Lesson 4, Solving Linear Equations. Today is 9/18. Okay. To solve a linear equation, what we want to do is isolate the variable. On one side of the equal sign by performing inverse operations. Get the letter by itself by undoing the math that has been done to the letter. So 3x minus 5 equals 25. 3 times some number, then take away 5 equals 25. What do I do first? Add 5 to both sides. It's going to give me 3x equals 30. Now what? Divide by 3. That'll give me x equals 10. Three times 10 is 30. 30 minus 5 is 25. Plugging that back in checks out. 3 times 10 minus 5 does give you 25. Any questions? Number 2, x over 2 plus 6 equals 23. What do I do first? Subtract 6 from both sides. (23 minus 6 is 17. What do I do now? Multiply both sides by 2. So apparently x equals 34. If I plug that back in, 34 divided by 2 plus 6. Well, half of 34 is 17. 17 plus 6 is 23, so it works. Oh, Lord, look at number 3. That one looks a little bit beefier. What do you think we do first? Sounds good to me. Let's add 1 to both sides. That's going to give me 3x plus 2 over 3 equals 3. What do I do next? Yeah, now that we've just got a fraction by itself on that left side, you want to get rid of the denominator by multiplying both sides by 3. That'll just leave the top 3x plus 2 by itself. Now this looks much more like the types that we've already done so far. Subtract 2, divide by 3, and we're done. When I subtract 2 from both sides, I get 3x equals 7. Then divide both sides by 3. Doesn't that come out to like 2.33333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333333 3, 3, 3, 3. Yeah, so you could call that 2.3 repeating. Or a perfectly acceptable answer is 7/3. If you want to leave it as that fraction, as long as the fraction is simplified, you go for it. 2.3 repeating or 7/3. Can you try 4, 5, and 6 right quick for me? I'm going to take a look up here at 4, 5, and 6. Let me know if you have any questions. Did anybody do number 6 differently? So, number 6, just one quick little thing. When we got to this step, 2/3 x equals 19, you can make that a one-step equation instead of multiplying by 3 then dividing by 2. The way is to take 19 and multiply it by 3/2, just the opposite fraction, the upside down fraction. 19 times 3/2 gives you 28.5. When you multiply a fraction by its reciprocal, the fraction upside down, they cancel out. Or you could have divided by 2/3, same thing. Any questions on 4, 5, or 6? Okay, 7, 8, and 9, they're not ready to solve yet because we need to do a little bit cleaning up first. One very common method of cleaning up is to use the distributive property. Or you might even have to combine like terms. So whenever I see parentheses with a number in front of it, it's telling me, hey buddy, you're gonna have to distribute something. So for number 7, what am I going to distribute to the 2x plus 3 in parentheses? Negative 2. Take that negative 2, multiply it to 2x and to 3. That 3 up front just kind of hangs out for a second. Negative 2 times 2x is negative 4x. Negative 2 times 3 is negative 6. Anybody have questions about what we did or why I didn't say 3 minus 2 is 1 and then distribute to 1? You just trusting me that you don't subtract 3 minus 2 first? Okay, cool. Why do we not do that? Yeah, that subtraction in the order of operations says, hey, multiply first. Very good. Okay, what do I do next? 3 minus 4x minus 6. Yeah, there's some like terms over here. 3 and negative 6. I'm going to write that as negative 4x minus 3. Positive 3, negative 6 make negative 3. And now that I've distributed and combined like terms, it looks a lot more like the types of equations we just finished solving. So add 3 to both sides. You get negative 4x equals 35. Then divide both sides by negative 4. You could call that negative 8.75, or that doesn't reduce, so negative 35 over 4. We feeling okay? Cool. Do you feel good enough to try number 8 and 9? Don't be too confused about number 8. It's just all the x's are on the right side instead of the left. Still do the same thing. Okay, if you want to check your answers, you see from ones like number 9, I know fractions are not our favorite thing, but it's a much easier way of saying that answer, because the decimal answer, my calculator kind of cut it off, but it's a long decimal. 0.41176477059. If it had told us to round to the nearest tenth or hundredth or whatever, then that would be a different thing. But the more concise answer is negative 7 over 17. Any questions on that? We're feeling okay so far? Okay. On the back, not much different, except we've got x's or variables on both sides. All we got to do is make them all on the same side, either all on the left or all on the right. It does not matter. Although I will say there's kind of like an easy way and a hard way to tackle all of those. So 5x minus 1 equals 4x plus 3. So 5 times some number minus 1 is the same thing as 4 times that same number plus 3. What I'll do first is, I don't like that there's x's on the left and right. So I'm going to move the smaller number of x's. Between 5 and 4, the smaller number is 4. So subtract 4x from both sides. That'll give me x minus 1 equals 3. And suddenly that's a super easy equation to solve. Add 1 to both sides. So it looks like that mystery x value is 4. You can plug it in. 5 times 4 minus 1, that's going to be 19. 4 times 4 plus 3, that's also going to be 19. Okay, look at number 11. Ew, gross. 6x minus 2 equals 12x plus 16. I don't know about you, but I'm one of those people that as soon as I flipped the paper over and I saw that 1/2 x, I thought, oh, who typed this paper up? Me. So how do we do that? Are any of y'all over there finding common denominators? Or calling it 0.5? Okay, can I show you a little secret that makes these super easy with fractions? Okay, you see how that 1/2 is kind of gross and we don't like it? If we multiply everything by 2, 2 times 6x, 2 times negative 2, 2 times 1/2, and 2 times negative 16. As long as you do the same thing to both sides of the equation, it's still kosher and it's still balanced. That's going to give me 12x minus 4 equals 1x minus 32. Now, if you had left that as 0.5x and subtracted 0.5 from both sides, that would probably give you the same, it will give you the same answer as well. You just end up with some decimals a little bit sooner. Then subtract x from both sides. 12x minus x is 11x. Minus 4 equals negative 32. Then add 4. Negative 32 plus 4 is negative 28. That comes out to negative 2.54 with the 5-4 repeating. Or negative 28 over 11. The little kill the fractions trick that I just showed you, be careful for ones like number 12. You can do that, but you're only going to multiply the 4 and the 1/3. Okay? Don't multiply the 2x plus 1 just yet. Don't multiply the 6x minus 3 just yet if you're going to try to get rid of that fraction. But, I mean, solving equations, there's like a strategy behind it. You want to make it as simple as possible. If I distribute 1/3 to 6 and negative 3, doesn't that come out to nice, pretty whole number answers anyway? Yeah. So, I mean, like, maybe I'm not going to do that little fraction trick here. I mean, if I make this 12 times 2x plus 1 and 1 times 6x minus 3, I'll get the same answer. But I'm going to distribute that fraction instead. And the 4. We get 8x plus 4 equals 2x minus 1. The nice thing about that little fraction trick is there's no fractions afterwards. The not so nice thing is it sometimes gives you bigger numbers. Any questions? Okay, try those other 6. We'll come back together in just a couple of minutes. Any questions on 13, 14, or 15? Okay, I'll give you just a couple more minutes to finish up 16 through 18. Any questions? Number 13 is 5 over 8 or 0.625. Number 14 is just negative 5. Number 15 is negative 7/5 or negative 1.4. Okay, sliding this on up. 16, you could either have 1/2 or 0.5. 17, just 1. And 18, just 0. Okay. Oh, okay. Okay. Okay, so go and put your name and today's date at the top of this paper as well. Okay, we're solving more equations, except instead of solving for x, we're solving for specific letters that have a specific meaning in this giant blank. Okay? So like the first one, 2a plus 5 equals 3a minus 1. To solve that, the first thing I'll do, we know this, subtract 2a from both sides. We get 5 equals a minus 1. Then add 1 to both sides, and we've solved that equation. Here's where the fun part comes in. Anytime you see a 6 below a box, you're going to put an A. So like in that third word, or second word, the third letter is A. And this one. And we'll just keep on scanning for 6s. Then do the same thing with D. I'm going to start by distributing 1/3. One third times 9d plus 6 gives us 3d plus 2. Subtract 2, then divide by 2. So I get that anytime I see a 1/2 in this grid, it's a D. We feel like we know how this works? Cool. The rest of the equations are hanging up around the room. You can do them in whatever order you want. Some of these equations will give you a butt ton of letters. Some of them might give you just 1 or 2 of the same letter. Okay? Fill it out until you get to this really famous quote by this really famous person.
I already know who she is.
Oh, somebody already knows who she is.
It's Maya Angelou. Oh, sorry.
I think I'll write that down.
Well, good luck spelling it if you don't know who she is. There's also space on the back for you to show your work. If y'all need a clipboard, there's plenty up here. If not, you can use 3-ring binder.